Welcome back, everyone. In this lecture, we're going to get a quick overview of the Recurrent Neural Network Exercises notebook for this section of the course. This exercise notebook has a lot of stuff filled in out for you, and really it's about understanding what to take from the lectures and fill in order to process another time series dataset. Let's get started by going over the notebook. In the next lecture, we'll go over the solutions. All right, here we are at the exercise notebook. For these exercises, we're using data from the Federal Reserve Economic Database and its electricity and gas utilities production. And we went ahead and made the data set a little smaller so we wouldn't have to train that much. And it goes from 1992 up to January 2019. So the data set, here's the official data set. It goes all the way back to the 1940s, but we're just going to be concerned with kind of starting around 1992. So go ahead and make sure you don't run the cells directly above example output. Otherwise, you end up writing over that example output. So we'll be performing the following steps, such as standard imports, loading the datasets, preparing the dataset, defining the model, training the model, and then evaluation. So go ahead and run this first cell. We've set up quite a bit for you as far as doing your imports, as well as reading in the data. The data is underneath the data folder, time series data, energyproduction.csv. And then the loading of the data frame should look something like this. Notice you have one column named IPG, and then the series, and then you have an index of this date column. And if you run this cell here, it'll go ahead and plot out the data for you. We can see there's a general upward trend, and it definitely looks like there's some sort of seasonality to this. So go ahead and prepare the data. We want you to divide the data into training sets and test sets. So we filled out a little bit here for you, but you can go ahead and then define these variables correctly. And if you run the code below and check your results, it should look something like this. Then we want you to normalize the training set. So we've set up this scalar object for you, and we want you to create this train norm variable. You can do it in one line or two lines, depending on how you like to think about the scalar. Then if you go ahead and run it, it should look something like this cell right here. Then if you prepare the data for LSTM, we went ahead and just copied and pasted that classic input data function that we've been using throughout this series of lectures. No real need to have you just rewrite this again. So go ahead and run this cell, and then set up your training data here, and then run the code below here to see how your training data finally looks. So again, I'm kind of separating things out into that list of tuples for the window and the labels. Then we want you to define the model. We want you to design a model that is a 1x64 LSTM layer and then a 64:1 fully connected linear layer. Also make sure to initialize the hidden state and cell state and only return the last predicted value. And feel free to reference the lecture notebooks as necessary. Then if you run this code, go ahead and set the seed the same way we do, and then create your model, and then you'll have this model come out here. Then we want you to define the loss and optimization functions. You can use any functions you want, but I would highly recommend you use the MSE, or mean squared error loss function, as well as the atom optimizer with a learning rate of 0.001. I'd recommend you just go ahead and use those. That way you can directly compare your results to ours. Then we want you to train the model. Don't worry about things like tracking loss values or displaying result. Just go ahead and train for 50 epochs. So after you've trained for 50 epochs, you'll go ahead and evaluate the model using the test set, and make sure to reinitialize the hidden parameters, the hidden cell state. And then before running the model, we went ahead and set up a little bit for you, and you'll go ahead and fill in this for loop. And then you'll get your predictions. Recall that your predictions will be normalized. So we want you to do an inverse transformation to get what we call true predictions in the correct format. And as a bonus, you can go ahead and plot out the result. And if you plot it out, you should be pretty okay for your prediction. So notice here we're kind of plotting against that test set range, and here we can see, again, against the test set range. And if you want, as a bonus, you can continue to forecast into the unknown future, but here, what we're doing is just comparing our values against the test set, since running that prediction is essentially the exact same process as forecasting into the future. All right, best of luck on this exercise. In the next lecture, we'll go over the solutions.